Assalamu alaikum warahmatullahi wabarakatuh. Today we are going to see how we export the Excel file coordinate from the Excel file to the reference model for pressure pipe from the source to the service reservoir. First, after opening the application, you have to see some setting, and you have to click this button, tools, then click the draw down, and here see this one. The unit must be in SI. There is two unit option here, the US customary and the SI. So you have to select the international unit. Also, in addition to that one, this one also must be the SI unit. Then we are going to import the Excel file from the Excel sheet file, which contain the coordinate X, Y, and the elevation, which means the easting, the northing, and the elevation. So we have to click this button, model builder. Then by selecting the file type, we have to browse to the file location. Then it will see it. I'm already trying, but it will see it. And the file say RM rising mean line for Busa. Busa is the location. Then next, this is 1 2 meter. Next and next. We here imported the only the coordinate XYZ, which means we are going to label only for junction. So at this point we have to select the junction, only the junction. We can just import all the file with one, but I think it's better this way is the better one. So the key field, the first key field or the first column say label, then X field say it's also X, in Y field say a Y. Here in the down say that the property under here you have to select the elevation to put the elevation for every junction. Then continue. Wow. Let me fix this one. I think there is a problem with the file. So let me go back and fix this for it. So let me export the file. I think I already fixed the problem. Then as previous step, you have to select this file and you have to make this one meter. Continue. This is one junction. Since we are already exporting only the junction, this one also X, this one is Y. Click on this one, set on the elevation, select here the property. Then next, next, and next to the end. Let me run and let me see what happened here. Yeah, see here. Let me use this one and go back to the tool for setting, drawing. Let me to make visible. Let me make this one 25. So maybe it will be visible. Then it's here. Or let me make more. To make more visible, let me make this one 40. see. I think it's visible, yeah. So here is the coordinate. I think it's okay. Here, let me define a little about this project. Here is at this point the source, the source locations, and the system has two tanks. One is at here, and the other is at here. So we are here expected to do or to draw the pipe, the pipe in all junction. So to draw the pipe, you have to select, go to layout and select pipe. Click on the junction and draw like this. Click also like this and continue like this up to the end of every junction in both sides, to this side and to this side, both. Continue like this, continue like this. Then we have T here. Start from here up to here to there and continue up to the tank, which is the service reservoir. Here for both tank, let me make this one. We have a tank, we have to put a tank here. We have also another tank, we have to put here the tank. Yeah. When we just put the tank, there is a four elevation that should be filed. This is the ground elevation, and this is the base of the tank. If your tank is the ground tank, don't worry. It was here the ground, so let me out the foundation of the tank. So the foundation can be a 50 centimeter. So add this one to 50 centimeter. 0.3, 7.3. Became 7.3. كذا ملسو. Never. Select this one. قاعدكم 7, 3. Mostly the base and the minimum are the same, don't worry. Can make the same. And the initial is, let's say our tank is in here, ground. So we have to add the height of the up to the inlet. Let's say 4.4. Let's say 4 meter. So add 4 meter on here. 61, I think. 4.5, yeah. 61. 4.5, which means it should be 80. The maximum also become 86 at 30 centimeter, 62.1. Like this, you fill all the other time. And lastly, after all the drawing, our system become like this. Here is the tank, it's all drawn. And also here on the other side, so here is the tank. All the parts are drawn, and we have to insert our pipe diameter depending on the discharge and depending on the demand and depending on the just the yield of the source. Here there is something here that you haven't seen, and we already drawn up to here. We started in Excel up to here, but below this it is a source, and just how we put the reservoir and the pump. Here is the pump. Let me let me change the color of the selection. Let me make it blue. Maybe it will be visible. Here is the pump, and here is the reservoir. And here we have to first we have to point out this junction. This is the location of the source. Then all the same, the location of the source, the x coordinate are the same with this junction, which means the pump and the reservoir are the same with the junction. There is just a technical property related with the and here to put how the pump and the reservoir should work below the junction point or where the source, the location of the source are. Then we have to go to the coordinate of the junction and the depths or the dynamic level or the pump position of the pump. Here on this project, it was already known from the completion report and geological completion report. The dynamic water level is around 195.1 meter. And here, since at these depths we have to put our or the pump position, we have to put our pump. Then here, since we wanted the elevation, we have to deduct from the y or from the northing and from the elevation this number for both. But to get the follow or to make to get a suction, just to get the suction, the pump should be below the reservoir, which means here we put the coordinate. Here is the junction 172, which means the location of the source. It is here 17 at this point. You have to take this coordinate and an easting or an x coordinate. All the pump, the reservoir are the same with the junction 172, but the northing and the elevation should be different to get the follow. And just to put the depth or the dynamic water level here for reservoir, we have this coordinate. This coordinate, the difference between this coordinate is around 195. I think it's around 195. Let me calculate this minus this one. It's 196. It's okay. Also, the pump should be below that. Minus is all the same with that. 95. So we have to put our pump at 95 and just our reservoir at 96. Let's calculate also the elevation. Here, let's say is equal to this one is the elevation of the location minus the number 195, and here is equal to this minus this one 6.1. Like this one, we have to put our pump and the reservoir. Then after putting the pump and the reservoir, by just before that, just we have to click on the reservoir the same this way. Click on this one and the pump also, click here isolatedly, then click on one of them. Here is the elevation, here is the coordinate. Let me try by putting this elevation, just these coordinates on the, just on the reservoir. Then let me put this one x, and take also the y here. See, it's already come to this one, to the same. Just let me put also the y. If I put the y, it became here and here. Then we click here. So we have to insert our coordinate like this. Open first the Excel file, then just bring the junction coordinates, this one and this one, including the elevation. Then by deducting the dynamic water level, you can put both pump and the reservoir. After putting the pump, we have to calculate the, just to know and to put the pump head, we have to calculate the just the head, pump head total. It's called a total dynamic head. We have a difference of here, we have here the elevation of the source. At the source we have an elevation of this number 7, something like this. Yeah, at the tank we have this one, so we have to deduct one from the other one. It's equal to this minus this, get this one. And also the the dynamic water level. So we have to add this number with the dynamic water level. You can see. Let's assume also there's another loss, the distance of whatever it is, but you have to consider and you have to calculate. And inshallah, in the next lesson, we will calculate in detail the every loss that could be occur on the system. At this point, we have to just, let's assume 20 meter for the loss. Then is equal to 20 plus this head. We have around 312, something like that. We have to put this head into our system. How? We have here pump. Let me cancel this one. It was for the illustration, so we have to cancel this one. Then go to the pump definition, and it's already put it here. If you want to put a new one, you have to click here, new one. By just, let me put the same with this one. This one is the already one, the existing one. We have to just to pump this just this discharge, and we have to put our head also in here. And in here we have select design points and the discharge and the head that we calculated already. The efficiency, take this point, take this one, and we follow it's around 7, I think 7 per second. Then it is the efficiency of the pump. It should not be above 85. We don't have a pump that above this number on the market. And the motor also, mostly of the motor, the efficiency of the motor is around 90. There's no more on the market above 90% of efficiency. Then we have to put our pump. Let me delete this one, or let me show you in a new. Select this one as a design point, put here the discharge, put here the head. Let me take, as we said, 12.8, something like that. Then make this one 85, this one also 7, this one should be also 90% of efficiency. Then it's already finished. Since we have already put it in here, we have to delete this one There's no need any additional. This is for you to show to know how I put it. This one. Then let me close this one. Let me validate my system. No problem were found on the system. Then after validating, let me run or compute the system. We got here follow stored, follow supplied. Since we put in this one, then then we have to see our result. Our result is here the pump. Let me see the report. Then our report say pump H will be 10. This one is for checkup. If you are not correct in the correct way, this one may guide you and give you the correct head according to your elevation and your landscape. Let me go to the junction. You have to check the head, pressure head. Your head should not be below 10 meter of a water. See, the minimum is 11. So it's okay. Maybe there is a mistake happened, but 10. This one, the one you see, is above just there is a two system and there is also a follow control at the point. Here we have a follow control. Don't worry for the zero number. At this follow control, it's already closed, but we have to use just not continuous, but closing one and using the other one. Here this one is closed and this one is open. So you have to just we have to carry this one only. That's where it came from. And just so we can see where this junction is located. Select on the drawing. It's already selected. The only one with the blue color is the one which is closed at this point and control with the follow control. So below this our system is okay, 10 above 10. So it's okay. If you want to if it's the shift of this one is today, you have to close this one by just clicking on this one and it's active. So you have to click on close, but we are doing this one, we don't have to close. Then I think it's enough. Then we should have to check the velocity. Your velocity shouldn't be below, should not be below, just below in the range of 0.6 up to 1.1 1.5. But at the manifold, which means at the point of where the pump and the reservoir is located, no problem. It sometimes goes up to 4 liter per second, meter per second. And don't worry, let me see this one also in detail. Here, the 01 is the closed portion of the system. We can see also the closed portion of the system by just selecting all of them and selecting in the drawing. The only closed one is this portion. So it's already closed. So we have to see the other portion of the system. Let me see the velocity. Our velocity is in the range. It's okay. It's between 0.6 and 1.5. 0.96, 0.96. So we are safe here. And I think it is enough for today. Have a nice situation after the next lesson. Assalamu alaikum warahmatullahi wabarakatuh.